Hello everyone, it's Benny, and as I promised in the last video, today I'm going to be showing you how to make Pong. And in this particular video, you probably won't be seeing too much excitement going on. We're really just mainly going to be focusing on repurposing this code we've been working on in the past couple of videos into something that's more game development friendly, so to speak. So that's what we're really going to be talking about in this video. So, without further ado, I say let's get started. So, any game you develop ever needs one thing, and that thing is a game engine. Every game, even Pong, needs a game engine in order to run. And I think a good place to start with that is clearly defining what a game engine is supposed to do, because I know a lot of people hear the word game engine and start thinking of all this next generation stuff that's like subsurface scattering and some sort of anti-aliasing stuff and all sorts of that stuff. But I mean, yeah, so those are cool things to have in a game engine. They help make your game look a lot better, but they aren't really what a game engine at its core is. And at its core, a game engine does 7 things. That's it. It can provide a lot of tools to do those 7 things as effectively as possible, but there's only 7 of them. So, what we're going to do is, since we are going to not only build a game engine, but we're going to build this in a very object-oriented manner, we're going to talk about the main class. Because right now, we've been doing everything in the main class, and that's just not the way things are going to work. So, we're going to, as we're talking about what the game engine does and how we're going to implement that, we're going to talk about the main class and how we're going to repurpose it to fit the role of the game engine. And really I shouldn't say the game engine, but more of the game engine manager. The main class is going to be the thing that tells the program to do the 7 different things. And that's why I'm going to call it the game engine management class. So, there we go. We now have a clearly defined purpose for the main class, and we have a clear idea of where we're going to get started. So, let's just go ahead and start running through the 7 things, and we'll just start moving things around as needed. Does that sound fair with everyone? Of course it does. So let's get started. So, the first thing a game engine does is it initializes some window. It creates a window, and it does whatever it needs to get that window ready to display the game. So, and that's the very first thing that a game engine does. And, if you notice in our main class, we already have 2 methods that do that for us. The Initialize display, which creates a window, and the Initialize GL, which initializes OpenGL and prepares it for drawing in the window. So we already have step 1 completed here, and in fact I'll just sort of leave this off to its own place and put a comment that says just initialize program. How about that? So there we go, that's the very first thing a game engine does. It initializes the program so that a game can be displayed in it. And that's the first thing a game engine does. So we actually are a little bit fortunate because we're already doing that. Now, the next thing that a game engine does is it initializes the game itself. It creates all the objects it will initially need. So in the case of Pong, it would create a paddle, a ball, an enemy paddle, and some walls, and it would also start initializing whatever it needs to start keeping track of score, and it would just prepare everything for a game to run. We are currently not doing that. So I'm just going to create a method called initGame, and I'm going to put it right above here. It can be private static void, it can be called initGame, and I'm just going to leave it blank for now. And this is the second thing that our game engine will do. Now the third thing a game engine does is it starts a game loop, and this will start a series of events that will happen over and over again, and these are the events that will occur every single frame. And it allows us a sort of frame-by-frame control over what's happening in the game, and that's sort of how we'll have to think of this. We'll have to sort of think of frame-by-frame, what do we need the game to do? And that's all done within the game loop. And as you can see, we've started a game loop here, so we're sort of done, but the game engine does 3 things within the game loop. the very first thing it does is it gets any user input that is, it just gets an user input, which is pretty self-explanatory. And if you think about it, it makes sense. If you're just thinking of a game frame by frame what has to happen, the very first thing you want to do is you want to know what input is being put in, because you're going to do something a little bit different that frame if the user is pressing the forward button and the shooting button, if you're like in some action game for some reason. It will do something a little bit different then than if the user is just, the user's AFK and just doing something else. So you'll need to know input information. And we aren't really doing that yet. So I'll just say get input. We'll create a method. I'll just put it above it again. Back void get input. And there we go. And again, we'll leave that blank for now. The second thing the game engine does in the game loop is it performs all the game logic. And this is things like AI, physics. So like in the case of Pong, it would move the ball along, move the player along, move the enemy along. It would make sure none of them have collided, and if they did collide, then like say the player hits the ball, then the ball would have to like reverse and maybe move around a bit. And it would do all that stuff. All of that stuff that happens in game logic. And I'm going to call this the update function, because that's usually what it's called in game engines. It's usually called the update function. It happens once per frame, all the logic that happens on a per frame basis. So here we go. We're going to have an update function. So, and of course, again, create an update function, and just leave it blank for now. And the final thing the game engine does in this game loop is it renders. It draws everything in the game as it is onto the screen. And that's sort of how we get the effect of things moving around. It does all the calculations to figure out what things are beforehand, and then it draws it to the screen. And it makes a lot of sense if you think about it, because you can't really draw the enemy at its next position if you don't know where it is yet. So that's why rendering occurs last. And as you can see, we sort of have some rendering code going on already. So I'm just going to create a render method, and just like every other time. I'm just going to paste this rendering code that we have in there, and slide it over because NetBeans likes pushing things over for some reason. And there we go, that completes our game loop. And it also completes the next 4 things the game engine does. So we've done the first 6, what's the final thing? Well, it's cleanup. Just do anything that's necessary to be done before the program closes. Because, if you think about it, if your game isn't really running, which is done in the game loop, then all you have left to do is just exit out of the game, because your game can't not be running and you expect the program to still linger. That just doesn't make sense. If the game isn't running, get rid of the game, it's done. So that's all done in the cleanup method. Anything we need to do before the game is finished running, that's what we do here. And that's it. That's all the game engine does. And of course, you can get really fancy into making all these things happen as effectively as possible, but at its core, this is all that a game engine does. So, there we go. You have just created your first game engine, or at least the roots of a game engine. We don't really have it in a state where it can power a game just yet, but we're pretty close. So, with that all out of the way, let's start implementing some of these methods that we have created. So before we get in and just start haphazardly typing code, let's stop and think for a moment. A game engine, generally speaking, is designed so that it can power many different games, not just a single game. So if you think about it in that sense, then you can't just type the code that will initialize Pong in the initGame method, or the code that will deal with input in the getInput method, or the code that will get input specifically for Pong, or the code that will specifically do all the game logic for Pong in the update function, because, well, Pong simply is not what every single game is like. Every game does these things a little bit differently. So, in order to preserve the concept of a game engine being able to power, theoretically, many games, I'm going to implement all these in a separate class, which, from an object-oriented standpoint, also makes a lot of sense, because we want the main class to just deal with managing the game engine. All the sort of management methods that the game engine has to do, all are supposed to be done here. So, and yes, that does mean that methods like our draw rectangle method that we created in video 4, it means that those will have to be moved to a different class later since they don't really fit the general game engine stuff. But we'll cross that bridge when we come to it. So for now, we're going to need some unique thing that deals with all these methods. So, what can we do? Well, in the world of object-oriented programming, the solution is make a class. So, that's what I'm going to do. I'm going to create a class. And this is going to be the game. This is sort of how our game engine is going to work. It's going to have a game that it's powering, and we're just going to implement the game class a little bit differently for everything we're doing. That way, if we wanted to have many games powered by this engine, we could just swap out the game class for whatever different game we want to play, and that would run absolutely perfectly. At least that's the idea. So there we go. So, now that we have the game class, what we're going to do is, in our initialize game method, well, first off, we're going to need a game that's kept track of by the game engine, because, I mean, it's not really much of a game engine if it doesn't have a game it's powering. So we're going to keep track of a game. We're going to have a game, I'm just going to call it game. In our initialized game class, we just need to create a new game. And the game's going to manage all its initialization by itself. We're just going to trust that. So, we're going to have getInput method. How are we going to implement this? Well, our game is supposed to implement its own getInput method because every game's input's a little bit different. So we're just going to do game.getInput, and we'll create a method in the game class that handles that. Now for updating, every game updates a little bit differently, so we'll just do game.update. And there we go, we've handled all the updating code. Now rendering. Every game renders a little bit differently, so we're just going to do game.render. Except, we're not just going to cut all this code and paste it in the rendering thing, because, you know, that's a little bit out of there. So I'm just going to delete the GL color and draw rect code, and this is where I'm going to put the game.render code, because if you think about it, every game, pretty much, we're going to want to clear the frame every frame, and we're going to want to clear the transformation matrices every frame. So, you know, I think it's reasonable to assume that every game wants to do that. So, I'm just going to leave that in the render method. And after we draw every frame, we're going to need to update the display. So, I think it's reasonable to assume that. And there's actually 2 more things that I need to do before I get into really doing the game. And that is, I'm going to need my game to have a static frame rate. And I don't need it to have a static frame rate, but it's just a little bit more code to handle games with dynamic frame rates, since if you think about it, the game loop's designed to handle things on a per-frame basis, so we need to sort of have to handle cases where frames aren't the same length. We'll have to adjust everything based on different frame lengths, like, for example, if I was lagging, one frame took 1.7 seconds, and my normal frame takes 1.3 seconds, I need to adjust to take into account, hey, this frame took 1.7 seconds, and yada yada yada. So, my solution to this is just set it to a static frame rate so that we don't have to deal with that. And fortunately, Lightweight Java Game Library provides an easy method for us to do that. It's the display.sync method. This will sync our display to some frame rate. And I'll just do 60 FPS, because why not? I mean, it's Pong. If you can't get 60 FPS on Pong, then wow. Just wow. But anyways, there's also one more thing we have to do. And we don't need to do this again, but this will get rid of a couple of visual glitches that we'll experience later on if we don't do this. And I know if I don't cover this, then there's going to be a lot of people asking me, hey, why is my screen doing this weird line thingy? So, yeah, that's the reason I'm going to do this. And this is after we just create the display, we're going to sync it to our monitor's frame rate. Because, in case you didn't know, every monitor has a maximum refresh rate, is the maximum rate at which you can display different images. So we're just going to sync our display to that rate, because if we don't, then we can get some really weird visual glitches if we try to display images faster than our monitor can handle them. The way we do this is do display dot, I believe it's set vsync enabled, and we want this to true. And this will just get to the monitor's frame rate. So there we go. We've pretty much set up. In fact, we've pretty much finished this entire game engine class. We do have a couple of errors since our game doesn't have the methods required yet, but that's okay. We can just create those really quickly. So public void, not static this time since we're doing object-oriented. Public void update. We'll have public void get input and a public void render. And there we go, we have the methods. And also, when we initialize it, it will activate the constructor, so I'll just go ahead and create a constructor for this object. And there we go. Every single game that we create will be set up pretty much exactly like this. And if I wanted to make absolutely sure every game was like this, I could create an interface, but I don't think we need to go that far with it. And you'll notice everything's green now. We have set up a game. Congratulations. So now that we're finally in the world of programming a game rather than programming a game engine, let's talk about Pong. Now, if you start thinking about all the different things that you need in order to get Pong working, like having different paddles, and having walls, having the ball move around, detecting if the ball has hit something, detecting if someone scored. If you think about all that stuff, you will pretty quickly come to the realization that we're not quite to a point where we can just sit down and program this just yet. So, we're going to want to simplify this problem of creating Pong. And I think the best way of doing this is using the magic of object-oriented programming. So, let's think about the board for a moment. If you think about the board, you have the wall, you have the paddles, and you have a ball. And that's pretty much all that's on the Pong screen. But if you think about this, you might notice that every single one of these has something in common. Every single one of them will need to more or less do something every frame. Every single one of them has a position on the screen. Every one of them will need to be drawn in some shape or form. So, really, you could sort of abstractualize all these, assuming that's actually a word. I have absolutely no idea. I just sort of... But I'm just going to go with it now. If you abstractualize all these things, you could say that, well, all these things are actually not paddles, walls, and a ball. They're just all game objects. There's some object that it happens to reside within my game. So, I am going to sort of go along with that and say, okay, everything in the game is a game object. And the game will just have this list of game objects. So, I'm just going to have a private array list of game objects, called object, and I'm going to have to import array list, and we haven't created a game object yet, but I'm just going to say, okay, everything in the game is some object that's part of the game, so everything's a game object. And now, if you think of it like this, the problem's a lot simpler. So, initializing the game, for the time being, is just saying, okay, objects is a new array list of game objects. And now, our updating and rendering codes have suddenly become infinitely simpler. We can just say, okay, to update, I'll just go to every game object geo in object, and I'll just update it. And rendering code, same thing. For every game object in object, just render. So, we've just implemented almost the entire game class just from that one thing. Of course, we still need to go through and implement game object and tell Java, hey, this is what a game object is, but hopefully you'll agree with me in that this is a lot easier than what we would have had to do if we didn't make this abstraction. So, let's go ahead and solve all these errors by creating the game object class. I'm going to right-click on my package and create a new Java class, and it'll be game object. I'll go ahead and click finish, and there we go. Before we actually implement this, though, I need to do something right here, and that's make it an abstract class. And the reason we're going for an abstract class rather than a regular class is, well, think of it like this. If I go to the highway and I point to almost any vehicle on there, then most likely I could say, hey, that's a car. Unless I happen to point to a motorcycle or something, then I can say, yeah, that's a car. But, as you know, there are a lot of different types of cars on the highway. There could be a Honda, there could be a Ford, there could be a Lamborghini if you're lucky. There's lots of different types of cars. But there's no one object in existence that you can just say, oh hey, this is just a car. There's nothing that has just a car associated with it. There's always some more to it. There's like, okay, this is a sports car, this is a limo. No, there's nothing that's just a car. And similarly, in our Pong game, everything is a game object. I mean, the Pong ball, the paddle, the walls, all of them are game objects. But there's nothing in my game at all that I can just look at and say, oh hey, this is just a game object. Nothing else, nothing special, it's just a game object. And that's the reason I'm making this an abstract class rather than a regular class. Because, I'm only going to have this as sort of a concept. There's nothing that's going to just be a game object by itself. So hopefully you understand why I'm making this an abstract class rather than a regular class. And now let's start implementing it. So, let's think. What is everything in our game going to have? Well, first off, I can tell you it's going to have some position on the screen. Because, everything has some place it is on the screen. So I'm just going to represent that by an X and Y coordinate. And I'm going to make these protected because I want things that are game objects to have this, but I don't necessarily want any class to be able to just come in and start modifying our X and Y values. So that's why I'm making it protected. It's going to be a protected float. It'll be X. I'm also going to have a protected float for our Y position. And now, I can sort of take this a step further and say, well, everything in Pong is going to be a square, or a rectangle. So, I can just store a width and a height for every single object. And I'm just going to store these as a SX and SY for size X and size Y. You can call them width and height if you want, but I'm just going to keep them SX and XY just because it's shorter. Yeah, that's pretty much the only reason. And as far as I'm concerned, that's all the information that every game object has in common. So, now let's talk about what methods they have in common. What functionality do they have in common? What does every game object do? Well, every game object has some update function. It has something that it does every frame. Because, if you think about it, it makes sense. The player paddle is going to have to... Every single frame is going to have to know what keys the player is pressing, and if he's pressing some key, it's going to have to move. And the NA panel is going to have to, every frame, run some AI algorithm to determine if it moves or not, and how much to move to make sure it hits the ball. At every frame, the ball's going to have to move a little, and it's going to have to determine if it bounces. So every object has something that it does every single frame. So I'm just going to have a void method called update, and I'm actually going to make it abstract, because I'm not going to implement this. And every game object is also going to have some way of being drawn to the screen. It's going to have some rendering method. And this is actually going to be exactly the same for every single object. If I have a render method, every single thing is a square. It's going to be drawn exactly the same way. So, this is where I'm going to be using the draw rectangle method that I've made in the main class. From video 4, I believe it was. Was video 5? I don't know. It was one of the videos anyways. It was the previous video where we made these. So, obviously these don't belong in the main class, because the main class is what's handling all of our game engine stuff. It's the primary class for the game engine. It's the game engine manager. So I don't want these here. drawing methods do not belong in the Game Engine Manager. So I'm just going to create a static class. It's going to be a draw class. And this is where I'm going to put these methods. So I'm just going to cut these out, and... oh, I think I just started record recording. Sorry. Didn't mean to do that. And I'm just going to put my draw rectangle methods in here. Now I'm going to get a lot of errors right now because I haven't imported anything. So I'm just going to import OpenGL, not with public static, but import static org.lwjgl.opengl.gl11.star. That'll make all my errors go away. And you know, just because I don't, in a class called draw, it's sort of implied that you're going to be drawing things, I'm going to take the draw out of the method name. Just because, if you're in a class called draw, I think it's kind of assumed that you're going to be drawing something. So there we go. We've moved our drawing methods into their own class. And now for rendering things, everything can be drawn exactly the same way. Just draw.rect. Actually, I want these to be public because I want everything to be able to draw, not just things in the draw class. So I'm going to draw a rectangle at whatever position the game object's at whatever width and height the game object's at. And there we go. There is actually the rendering code for every single object in our entire game finished. So if you're just here for OpenGL, you may as well leave now because all the OpenGL coding for this game is completely done. We're done with OpenGL in this game. We just have to implement the game object now, or game logic now. So there we go. Now we need to go ahead and finish implementing the game object class. So what else do we need in the game object class? Well, I think it's safe to say that I'm going to need getters for all these variables. I don't need setters because I don't really need to change these outside of whatever class it belongs to, but I think it's safe to say I'm going to need some getter methods so that I can know about the location and position of whatever the game object is. So let's create getter methods. I'm going to create a public float getX, and it's going to return x, and similarly on a public float getY, it will return y, public float get public flat, interesting data type, public flat sx, get sx, and return sx, public float get sy, will return sy. And there. Now, when I implemented this off camera to sort of experiment, I actually discovered that there's one more... oh, public float get sy. There's actually one more method that we'll need. And it won't be completely obvious why we need this method just yet, so I hope you'll just bear with me and take my word for it that we'll need it, and it will make sense when we actually sort of implement this. And if you were implementing this on your own, and this is all you did, that's fine. This is all I did when I implemented this on my own. And in fact, I didn't write the render method by itself, and I ended up going back since they were all the same. So it's okay to sort of go back and discover as you go along. But I'm just sort of letting you take advantage of the fact that I discovered on my own that you need another method. And yeah. So this extra method that you'll need is finding the center of the game object in Y. Not X, just in Y. So I'm going to create a public float, get center Y, and now we have to deal with calculating the center of the object in Y. And here's how I'm going to demonstrate that. First off, I'm going to create just a Pong paddle, just because why not? For sake of demonstration, and oh dear, I think I might have just screwed something up horribly. Okay, there we go, never mind. So now this is my game object. It's my Pong paddle. I know it's black instead of white, but that's okay. We can have multiracial Pong paddles if we really want to. It doesn't really matter. So, let's talk about the way we're calculating this. When I'm drawing with my X and Y, as I have it implemented, that will draw this corner right here. This is the X and Y coordinate of the object. It is this corner right there. So I need to figure out how to get the center of it. And right now I know that the size in Y, so, oh god, that's a bad S, wow. So SY is sort of the size this way. That's the size in Y. So, if I want to find the center of this, well, that's right in the middle of this length, isn't it? So I'll just take SY, and I will divide it by 2. And that will get me this amount right here. But of course, that isn't really quite good enough, because while that does technically tell us where the center of the width is, it doesn't tell us where the center of the object is, because the object's also in some position. So the way I do this is actually a lot simpler than it sounds. I'll just need to take whatever y-coordinate this object's at, and just add it to this. So this is how we're calculating the center. It's being drawn based on some point on the screen, and this is the y distance. So I take the y distance, and I add that to half of the length in y. And that gets me where the center of the object is. So hopefully that makes some sense to you. So for get center in y, I'm going to return whatever my y value is, plus sy divided by 2. And congratulations! You have completed the GameObject class. And that's pretty much everything we'll need to do there. So, if every error should have already gone away here, and we have actually a lot of the framework of our game already done. But there's still one looming problem in our game. If I have the ball and it's moving across the screen towards the paddle, and then it hits the paddle, how do I know when it hits the paddle, and how do I handle the case that it hits the paddle? Yep, that's right, our game needs a physics engine. But it's okay, because our physics engine is actually going to be really simple. All we need in our physics engine is simply to determine whether or not two game objects have collided, because that's really all I need to determine, right? If I take the ball and the paddle, I need to determine if the ball and paddle collide, or if the ball and the wall collide, or if the ball and the enemy paddle collide. I just need collision detection. So it'll be a very, very simple physics engine. But it's still, it's still a little bit more difficult than you might expect to handle collision detection. So let's go ahead and create a physics class. And this is going to have all of our physics methods, which in this case is just determining if two game objects have collided. So that's what we're going to do. So we're just going to create a public static Boolean method, because we want to return true if they've collided and false if they haven't. Check collisions, and I'll take in two game objects. So I'm going to take in game object GO1 and game object GO2. And now we have the issue of handling whether or not two objects have collided. So, here's sort of my thinking in handling this. So I'm just going to quickly draw out some really simple objects. Draw something in there. Draw an object here. And I'll draw another one. Draw an object here. And draw an object here. And draw an object here. And finally, one object here, and one object here. So, there we go. I have my 6 example objects out. Now I'm going to sort of look at these in pairs to sort of explain to you how our collision detection system is going to work. And hopefully you've already figured out which one shouldn't be allowed. But, before we begin, let's just look at this. And remember, our game works on a frame-by-frame basis, so just keep that in mind as I talk about this. I have these two objects right here. And if you look at them and ask, hey, are these objects colliding? You say, well, of course, they're not colliding. I mean, it's obvious. There's this huge gap between them. How could they possibly be colliding with one another? And if you look at my second pair of objects, you'll notice the same thing. You'll say, well, there's still a gap. There's a tiny gap between them. They can't possibly be colliding. But when you look at our third pair, you'll say, okay, there's obvious there's some collision mishap here, because they should not be intersecting with one another. Our physics engine should have been smart and picked up on that, and then just said, okay, there's two objects that collided, and this shouldn't be allowed. So, obviously our physics engine got lazy on our third example right here. But this gives us a pretty important sort of lesson here. If you look, the difference between the objects that are colliding and the ones that aren't colliding is that the ones that have collided have intersected. And, of course, that's bad. We don't want our objects to intersect with one another. But that gives us a pretty clear idea of how we're going to handle collision detection, since we don't need a really advanced physics engine. And the way we're going to handle it is just simply, we're going to say, okay, have these two objects intersected? If not, well, something has to change because two objects aren't supposed to be allowed to intersect. And that's all this method's going to do. It's going to take the two game objects and determine if they've intersected. So now we have the issue of determining whether or not they've intersected. This is actually a lot easier than you might expect at first. Now, the first thing I'm going to do is, well, actually I'm going to sort of explain how I'm going to do this. In the Java development kit, there's a library set called the AWT library, and this contains a rectangle class. And this class, fortunately for us, has an intersection method that takes two rectangles and determines whether or not they've intersected. So I'm going to sort of leverage that and use that to determine whether our two game objects have collided. So create a rectangle, I'm just going to call R1, and just create a new rectangle. So this has to accurately represent our game object. How are we going to do this? And I'm first do Control-Shift-I, just import java.awt.rectangle. And so how do we create the rectangle? Well, the rectangle class takes four parameters. First, it takes a position in x and y. So just say, okay, alright, I'll get my x position, and I'll take my first game object and get its y position. Now it takes a width and a height. Well, fortunately, I'm storing this too, so get sx and GameObject1.get sy. So there we go. We've created an accurate rectangle that represents this, which I'm getting an error for some reason. But you'll notice we are getting an error, and that is because, well, rectangles in the java.awt world do not take floating point values. And we're storing our rectangles x, y, and positions in floating point values, and that's not good. So, since we are doing this every frame, we aren't expecting drastic changes in frames, and we aren't expecting decimal places to make a huge difference, I'm just going to say it's safe to cast all these as integers, because we don't really need all the extra precision when we're doing physics calculations. And this is how we're going to create both the rectangles. So for our second one, we're going to do the exact same thing. And we're just going to take GameObject2 instead of GameObject1 for all of the parameters. And now comes the hard part. How do we determine if they're intersected? Well, like I said, java.awt contains a method for this. So I'll just test if rectangle1 intersects rectangle2. That's it. This is our entire physics engine for Pong. Hopefully no one's mind was blown in the creation of this physics engine, but that's okay. Now this really is all the framework we need to create Pong. So, there you go. I hope you enjoyed. I hope you managed to make it through all of this. And yeah, because now we have everything we're going to need to really start creating the paddles and the balls and the walls and everything that actually goes into Pong in the next video, because we've already laid the foundation in this video. So thank you, and I'll see you in the next video, where we will be leveraging all the stuff we've created in this video to create actual Pong. So thank you, and see you in the next video.